Hiya, so in this video I'm going to talk to you about pulleys and how pulleys are used in mechanics and how to solve problems involving pulleys. Well, pulleys are quite simple, okay? What you've got is here a circle representing a pulley, and then either side of it you've got a what's called light inextensible string, and the string is effectively wrapped around the pulley. And say you've got one object here and you've got one object there. Quite simple, what will happen is the heavier object will fall and the lighter object will rise, okay? So suppose this object here has got a mass of 5 kilograms and this object here has got a mass of 3 kilograms. Can you see what's going to happen? The heavier object is going to fall downwards and there will be an acceleration vertically downwards. In turn, this object here, that's going to rise. That will be vertically upwards. Now, when this is modelled with a light inextensible string, what that means is the accelerations are exactly the same. So it's the rate at which this falls is going to be the same as the rate at which that increases, and that's really important, okay? What are the forces acting on this? Well, clearly you've got the weights for each object, okay? So you've got 5g for this mass, and here, even though this one's moving upwards, you've got 3g for this mass, okay? But you've also got tensions, okay? You've got tensions. Because when you've got an object connected with a light inextensible string, you've got tension in that string, haven't you? And so you'll have a tension there and you'll have a tension there, okay? If you're being complete, then as you might have seen with the connected particles, when you've got, for example, a car tow and a trailer, you know that there are effectively two tensions, equal and opposite. What these tensions do is they effectively act on the pulley. Okay, if you think about it, this pulley is going to effectively feel, if it could feel, okay, the weight of these objects via this string, and we call that the tension force. So you've got two tensions effectively act on the pulley downwards. Okay, so a common question is, what is the total force exerted on the pulley by the string? Okay, and it's going to be those two tensions there. Okay, quite commonly you're asked to find a mass or an acceleration or a tension. Okay. If you're given the mass, okay, it's fine. Otherwise, you're asked to find the accelerations. The thing to do is treat the particles separately, okay? So you've got this particle here. Let's just call that particle A, and this one particle B, just for simplicity. Okay. So if you call that particle A, then what are the forces acting on A? Where you've got the weight acting downwards, and because A moves downwards, that's going to be positive. And then opposing that, you're going to have tension, aren't you? So subtract T. And that's equal to the mass times acceleration. Remember, F equals ma, and the mass being 5a. So you got that. And then for particle B, that's this one that's moving upwards. Now, because this one's moving upwards, the tension this time will be positive. Okay, and opposing it in the opposite direction is the 3g. So you've got T subtract 3g, and that's equal to the mass times acceleration. Okay. So can you see what you end up with is two simultaneous equations, very similar to the car tow and trailer type question. Okay. I love those car tow and trailer type questions, they're great. But despite the fact this is a pulley, you should be able to see it's pretty much the same thing going on. What you can't do with pulleys is effectively treat this as one system overall. Okay, don't do that. Okay, you get into a total mess. Okay, and for most of the time it's completely wrong. You need to treat the A and the B as two separate objects. Okay. The easiest way of solving these simultaneously is to add the two together. So when you add the two together, the negative T and T will cancel, of course. And you're left with 5g subtract 3g, so that's 2g, is equal to 5a plus 3a, which is 8a. Okay? And then you've got a is equal to 2g over 8, or 1/4 g. It's quite common to leave g in the answer. Okay? You don't have to, but it's quite common. Otherwise, you just work out what a quarter of 9.8 actually is, okay? But I would leave G in the answer there, okay? Then we can work out what T is. We can use equation 2 to do that. Sorry, I'm just squeezing in a little bit here. So you've got the tension is equal to 3A. Well, we know A is 1/4 G, so that's 3/4 G, and then added to 3G. Okay, so 3/4 G plus 3G. So 3 is 12/4, isn't it? So that's 15 over 4 G. Okay, so very, very common. Okay, work out the acceleration, work out the tension. Going back to the question I posed earlier, what is the total force exerted by the string on the pulley? Well, you've got two lots of T here, haven't you? You've got T and T. And once you've found what the tension actually is, you can write it down. So 15/4g multiplied by 2. So 15/2g. Okay. That's effectively it. Okay. That is effectively it. Sometimes common questions are, explain how you use the fact that you're modelling this as a light, inextensible string. Okay, well, the two tensions are the same, the accelerations are the same. Before I forget, also the pulley is generally smooth, okay? In reality, not always the case of course, but in the syllabus that we're dealing with, the pulley is treated as smooth, okay? And that also means that the two tensions here could be the same, the accelerations could be. Just modelling it as a smooth pulley just makes things so much simpler for us, okay? I'm hoping you found that useful, okay? Coming up with some more examples and using pulleys.